Well, welcome to a rather damp and rainy Monday night here in the UK. In the last video I did say I was going to start to have a look at making these jigs for these cotter pins. Now, looking in the instruction manual, it mentions here a different jig is needed for each shaft size, and I've got 1, 2, 3, 4, 5 on there, so that's 5 jigs. Now we'll see what we can get out of this piece of material. Got sizes 5/8 thick. It's a little bit thicker, that I think it's, oh, might actually be 5/8. No, it's not. I've got 5/8, I've got 7/8, I've got 6/8. That's better. Or 3/4 of an inch even. Yeah, go figure. It's been a long day at work. And I need 5 off. What have we got? 1.5 inches long. So basically 1, 2, 3. Right, let's have a look at what the other way then. 1.5 inches that way, and that's 3.5 inches. So I might be able to get 1, 2. How long are we? 1 there, 1 there. Maybe 1 there. I could possibly get, depending on how good I saw it, I could get 6 out of this. I'd say the sizes aren't totally critical, as long as you're within these holes. You've got a decent wall thickness, so these holes don't collapse or distort. So the next thing to do is to have a file of this and an add up to make sure I can actually get the amount of jigs out of one piece. I'd rather try and get it out of one piece and see how we go. Well, after a bit of digging around in the boxes of bits from time gone by, I've found this. It's about 2 and a bit thou down. Now I've just cleaned it up. Off 1.5 inches, so I think that'll do. I might just flick these faces, but I'm going to be able to get at least 5 out of that without a problem. We'll see how the rest of it cleans up, but it's going to miss out a load of work there, because all I have to do is just chop it off and flick the faces up maybe. If it's pretty square, I'll just get on and start boring them all. Okay, I promised to do some cotter pins, and I'm going to do some. But what I'm going to do first off is drill this hole. I've been getting a little bit in front of myself, and I think I'm going to go back and catch up, if you understand what I mean. Now, I've decided to do these cotter pins pure and simply out of sheer curiosity, and I thought I'll just give it a go. So this is, he says, trying to remember the name. The right hand base head. Some of you will notice I've actually drilled the holes in here, and I don't think it was in the video. If it wasn't, I'll recheck, and I think I've got them and how I did them. You'll notice there is an extra hole in there, and that was a drop bollock, but never mind, you're not going to see it with the dust seal. I've put extra ones here for my purpose later on. This because it tells you to make up a sacrificial plug. This is what I had holding the two together, and it will be my sacrificial plug. Now, the first thing is the maths for it all, and this is how they work it out. The offset is half the diameter of whichever bar you're doing, plus the diameter of the stud. Not the hole that you're going to drill, but the stud. In this case, it's an M8. It'll be an M8 stud that will go down for the handle, plus 20 thou if you're in Imperial, or half a mil, because I'll be using an M8 stud. So all of this is metric. So if you look at their formula and you work it out yourself, half of the bar, 25.4, is 12.7. Half of M8 is 4, plus the half a mil is 17.2, the offset. And if we turn over the page, that's just for this relative hole, 17.2. What they're giving you here is you will have half a mil where that thread is. There'll be half a mil this side of it. I'm assuming when it tells you to make two different sizes of cotter pins, you've got 13 and 10, so this will be a 13 mil one, because obviously otherwise you're going to have a wall thickness of a mil a side, and plus the half a mil, that would give you half a mil wall thickness there, which isn't going to work. And you've got all this surface area there. Now, these people that are far brighter than me have worked out the coefficient of, wherever he says in the destruction books, the coefficient of things holding it. It's the static coefficient of friction for dry steel on steel is 0.7 versus brass, which is 0.35. I've not got a clue what that means. I think it means it grips it more. So this is what I'm going to have a go at doing. And I wondered, it's the chicken and the egg thing, what do you make first? And I was going to make a dummy up first, but I thought, no, not going to do that. The first thing I'm going to do is this hole, which is going to be a 13 mil reamed hole. Now, I've been waiting on my reamers have turned up, and I've looked at the casting, and there seems to be enough room. So what I'm going to do first, because I'll reamer it out with this, that dummy bar, that bar in, sacrificial bar, but I'll make sure my reamer's cutting to size. Oh, that's my phone. And the thing is then, once I've got that size, I can make them pins a good sliding fit in there. I can do the blanks so they fit good in there. It's I think it's going to be a custom one for every one. I mean, the reamer should cut the same, but we're down to a blind hole here. Some of them aren't. Some of them you can ream right way through, but I've got a blind hole here, so I've made sure I've gone and got myself a machine reamer. We can go right to the end, unlike a hand reamer which has got a taper, slight taper, and it will not clear right to the end. Obviously they're going to give us a depth somewhere on the drawing. There is a depth. It'll give you to drill the hole. Spot face 28.5 deep. Now it does say if you're going to make your cotter pins, they want to be 1/4 of an inch length each. Now you do then trim down to suit. So this depth, the second part of it there, isn't going to relate to the length of the cotter pin I'll be doing. What I've got to do is have clearance. Lots of drawings messing around. As you can see, we've got a clearance there, 2.4mm. Then you'll have a clearance, a space clearance in between, so that the two can clamp together. And then this is a sleeve with no thread in it. It's just clearance for the stud. And obviously you can imagine when you tighten this handle, they pull together, and this is going to pull on the bar. The optimum way is to machine these in situ, but I'm going to have a go at doing these jigs. Sorry for the long-winded rant about things, but that's the way it is, and that's what's going to be next. Okay, right, got the iron base secured in the vise. I have a parallel under there. It's not a brilliant finish, so I suppose a round bar would do. Checked again the 1.5 feeler, and I'm using this to check that the whole thing's vertical. We'll have a look at the clock. That's as near as I can get it. And I've also, like what they were saying, this was my original spacer when I had the two together, and I've cut it down to 1 millimetre less than what that dimension is across there. So this is going to fit in there. This is so that when we drill this hole, it doesn't chip the ball. And the other thing is, as they say, if you use this, you can use it as a guide to find the centre of your bore here by obviously touching on, dividing by 2, moving in, and keeping the backlash going the same way. So I'll always be going, I'm going to go that way, and then I can pitch across the dimension of, I think it was 17.2, which should give us our reference for the hole. Now I've also measured the thickness of this, which so I can get the depth again, which is about 28mm. In essence, it wouldn't really matter if it broke through there, because we put in almost like these two cotters are going to sit in there, and once the shaft is in with the cotter can't come out because the shaft is holding it in, and you've got the threaded stud in there. So next thing to do, we'll get this dialed in and we'll pitch across. Okay, I pitched across half the distance, whatever that was, and eyeballed it to make sure that this lug's round about in the centre. I've pitched across from the centre the 17.2 that we worked out before with the formula they give you. And also the other added benefit of doing this one first is it gives you the offset so that you can check the formula and you can see how it works, and so they give you the size as well. Now it does say the original drawings give you a 5/8 or a 16mm flat on a here, which it says you can use for dressing up, or if you want to put the original sizes in for the handles. Now I've got a 20mm cutter, and all I'm going to do is get this nice and flat on here, nice flat face, and I can centre drill it, start to drill it, and get ready for doing the reamer. Right, I'm back on my zeros now, and I've swapped out for a centre drill, and I've also had a measure along this lug. They've got 1 inch and 1/8, and that puts us pretty close to the bottom of the lug. But if you was to break through, you're going to break through into the casting. but there's enough room to drill down there. There's enough to do, close enough to about 30mm, which is about 1 inch and 1, 2, going on for 3/16, I think. Anyway, let's do the centre drill first. That looks pretty central. Now even the good professor talks about drilling, boring, then reaming, because you're breaking into this sacrificial sleeve. So I've got an 8mm drill in here because that should miss the plug by 1/2mm that way. That's the idea, because it's supposed to have a 8mm stud down there in the cotter, which should just be 1/2mm off the bar that's going through. So fingers crossed. Right, what I've done now to give my slot drill a bit of a chance, I've got a 1/2 inch drill in here, and I just want to almost like countersink it so I can give, I've got a 12.5mm cutter, and I just want to give it a good start instead of starting basically on a flat face. Well, I've just measured that and it's spot on, 1/2 inch. I'm going to try with this drill and then put a reamer down. I'm going to go down as slow as I can and just see what it feels like when it starts to hit the steel. I've checked with the square round the side here again, make sure that this thing hasn't moved, and fingers crossed it hasn't. Feel it ever so slightly on the bar, but everything else seems to be steady, and I've just gone past 23 mil. Now what I am going to do, I'm going to swap out now. I've got a 12.5mm cutter. I haven't got a 1/2 inch. I've sent off for one. It'll arrive after I've done this probably. But I'm going to just flat bottom it as good as what I can. Right, that's it. It's a 12.5mm cutter. It's the best I've got at the moment. Let's pick a reasonable speed. That's approximately my 28.5mm depth that I got before. Right, that's properly zeroed out. So I want, if I can manage it with this hole now, 28.5 mil. Just make sure we're going the right way. Oh yeah. Well, I like to cook my ream as slow if I can, and obviously it's cast iron, so we're not having any lubricant whatsoever. We might just have to watch out for swarf build up at the bottom of this hole. Just gone past 22 mil. 25, 6, 7. I've got 8.8, 28.8 on that now. What I did do as well, I did check against that lug with the square, and we seem okay. So what I'm going to do now in real time is we're going to have a look at it and see how we've managed. Right, now, first off, we've got a nice cut out there, which as far as I'm concerned, that should be great for our shaft. So I'm happy with that. Let's see what this looks like. First off, see if we can get some light in there. We can see the cutout. Empty the rest of the swarf out of the way. That's not too bad in there, I don't think. You get a better view. There we are. So what I need now is to produce some cotter pins. Get all this lot cleaned up.